Everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it. Pause the video, come back, we'll do it.
No.
And I will read it carefully. An artist decorates square plates using the same pattern of blue and green tiles, where the ratio of blue to green tiles is 3:2. For a certain plate, the artist uses 120 blue tiles and 20 N green tiles. What is the value of N? Interesting problem. Okay, so it's a two-parter, isn't it? So first you have to solve for the number of green tiles, and then you have to solve for N. So
Let me write it. Number of
go ahead.
is equal to 2/3 of the number of blues.
Wow.
Which equals 2/3 of 120, which equals, well, a third of 120 is 40, so that's 80. And 80 is the number of green tiles, equals 20 N. So N has to be 4.
Wow, that's where Seth's PhD in math really helps him. Because I have to do it a little slower, because I don't have that same level of confidence. I would do it as a ratio problem. And I would say blue to green, blue to green. And they tell you blue to green is 3:2. And blue is 120. X is green. So I would solve for X. If I was smarter, I would have put green in the numerator, but I'm not that smart. So it's 3x is equal to 240. So x is 80, and I get the same answer as Seth.
Yeah, well, the thing is, the way I wrote this down so quickly is that I knew that this meant that one of them is 2/3 of the other, and the other one is 3/2 of the first.
Oh, and
The ratio of blue to green means that the green is more. That the blue is more. So the green is less. So the multiplier is less than 1. That's why I picked 2/3. That's how I thought of writing 2/3.
Right.
I was so confident about it.
Right. So you knew that the ratio, they were fewer greens than blues. Because
it's a blue to green. You don't know. It's blue to green.
Yeah.
Is 3:2. So more blues than greens. For every 3 blues, there are 2 greens.
Right. Yeah. So you're right. So if they tell you the blues, there have to be fewer greens.
Yeah.
And the only ratio you have to make anything fewer is 2/3, because that's less than 1.
Yeah.
Yeah. So that's a really smart, efficient, fast way of doing the problem.
Yeah.
Yeah. I mean, writing the ratio takes maybe 15 seconds longer.
It's a waste of time.
Yeah, well.
You could do it.
Yeah.
Point is...
you run a greater risk solving this equation.
Yeah, but you have greater benefit getting a higher score. You have more time for the hard questions.
Right. So, if you could see a pattern, this almost comes down, I guess.
And then you could check. And then, of course, you check. You could then check. Well, that is 4. The number of green tiles is 80.
Yeah.
And
120.
And 80 consists of 2 groups of 40. And 120 consists of 3 groups of 40.
Right. Yeah.
So it verifies the ratio of blues to greens is 3:2.
Yeah.
Check it.
Yeah. Okay, good. So we're basically done. I asked the different questions.
Back when, criticism of math teaching was was that the teachers demand that you solve a problem in the way they teach,
Mm,
even though independent thinking about the problem could give you a solution
mm,
also,
mm.
and that the thinking that you make up yourself is just as good to solve the problem as what the teacher teaches.
Yeah.
But they so it discourages people from thinking on their own. Or people who think on their own are given negative feedback.
Right. 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 Right.
Yeah.
Yeah, I'm just taking a note because I think we should start changing one of our questions, which we'll talk about in a second. Yeah. Yeah. So that leads to the question I was thinking we should change. One of our questions we ask is how it's different from a school test. Rather than ask that question, we should ask, is there a shortcut to the problem that if you used at school, the teacher may say, well, I wanted you to solve the normal way. And this is a classic example of, yes, there is definitely a shortcut for people who see the pattern and understand what Seth was talking about, that there have to be fewer greens and blues, and the ratio of the ratio that you use to reduce the 120 is 2 to 3. And as soon as you see that, boom, you just hit 120, reduce it by 2 over 3, and that's immediately the answer. And you do not have to write the ratio. And you do not have to do the problem linearly like I did. I
Well,
like to.
I see another way of solving it now.
Yeah.
The ratio of numbers of blues to number of greens is 3 to 2.
Yeah.
You're told that you have 20 n green tiles,
Right.
which means that you have n bunches of 20 green tiles.
Right.
Well, for each bunch of 20 green tiles, there are 30. There's a bunch of 30 blue tiles. So how many bunches are there? It's the number of 30s that go into 120.
Yeah. Right. Yeah.
N is the number of bunches of 20 green tiles, and also the number of bunches of 30 blue tiles. Because for 3 to 2 means for every 30 of blues, there are 23 greens.
Hmm. Right.
So that's how you could
Yeah.
solve it.
That's another way of doing it. Yeah. Yeah.
Yeah.
Yeah. Yeah. Okay. So then, yeah, this is a classic example. There's a good example of how one sees that pattern, one can do it in a faster way than one would do it if you did it a more linear way. Do you start with the guesses? Well, there are no guesses. This is a free response, so you have to actually answer the question. Calculator, not really. Hopefully, you do not need a calculator to do these calculations, but you could use a calculator if you need it. And the main idea, how to deal with a ratio problem. That is the main idea that they're trying to see whether you know how to do. And it's a two-part ratio problem, not just one ratio. They're not asking you, if given 120 blue tiles, how many green tiles. It's a two-part ratio problem. But the essence of this problem is really learning how to do a ratio problem. And you can either do the shortcuts that Seth pulled by using sort of common sense and understanding what ratios mean, or you could do the more linear approach, write the ratio with units, solve for what you need to solve for, and then finish the word problem. I guess we're done, right?
Yeah.
Yeah, we're done today. Okay. So I'm Joel. I have a PhD in mechanical engineering. So there's a PhD in math. We're brothers. We come from different backgrounds, same family, but different educational backgrounds. We're different people. We come to different approaches, and we're here to offer suggestions and approaches on how to deal with the SAT math questions. So you should study, you should practice as many SAT questions as the College Board gives you. They give you 4 digital tests. Take them all, study from them, whatever topics you're weaker on, go to Khan Academy because they partner with the College Board. And the Khan Academy has about 20 to 30 questions per each topic, even individual topics on the SAT. And you can practice on those 30 or 40 questions to get a sense as to what you can expect on the test. Study your weaknesses and learn from your mistakes. That's a really important part of study. Okay, so I guess that's it.
That's it.
Please give comments on our videos. We take all the comments very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com.
And the email address is written on the homepage of this channel.
Exactly. Great. Okay, everyone, have a great day. We hope to see you tomorrow.